Hello students, welcome to the class. In this class, we will discuss line and plane in space. Consider equation of a plane in vector form as r dot n is equal to d. Here this vector r is position vector of any point on the plane. This vector n is a vector perpendicular to the plane and d is scalar. Also consider equation of line in vector form, that is r is equal to a plus lambda times b. Again, here r is position vector of any point on the line. This vector a is position vector of point through which line is passing, and b is a vector to which line is parallel, and lambda is parameter. So we have now equation of plane and equation of line in vector form. Okay, now how this line and plane are positioned? For that, consider different possibilities. Suppose this is a plane r dot n is equal to d. Now suppose this line is parallel to the plane. So we draw a line parallel to this plane, but this line is not on the plane. We are considering line is parallel to plane. Vector along this line is b, and this line is passing through point A, whose position vector is vector A. Now where is this vector n? This vector n is normal to the plane. So let's draw a vector n which is normal to the plane. This is perpendicular. Okay. Now we can see when line is parallel to this plane, vectors b and n are perpendicular. So we can say for this position of line and plane, b dot n is equal to 0. But also this line is parallel to plane but not lying on the plane. That means we have to ensure that point A of the line is not in the plane, and for that we put this point A in the equation of plane. We have a dot n, and this is not equal to d. If this dot is equal to d, that means this point is lying on the plane. But since line is parallel, not lying on the plane, this point A is not satisfying the equation of plane, so that we have a dot n not equal to d. Okay, now consider line is perpendicular to the plane. So let's once again draw the plane. I am drawing the plane as a cloud because actually this is the part of the plane, because plane is infinite in the space. So this is one of my ways to represent plane. So here we have again plane r dot n is equal to d. Okay, now we have a line perpendicular to this plane. So let's draw a line like this. This is foot of perpendicular of line on plane. This dotted part is that of line which is lying to the back of plane. Again the line is visible. Okay, so this is our line. Okay, now this line is passing through point A. So here we have point A. Position vector of point A is vector A, and line is parallel to vector B. Okay, also normal to this plane is vector n. Okay, now here we can see that this vector n and b are parallel. For that, the condition you can write this way: vector n is equal to some constant alpha times b. Because these two vectors are parallel, so we can write n is equal to alpha times b, where alpha is scalar. Also we can say when two vectors are parallel, their cross product is 0. So this is equivalent to n cross b is equal to 0. So here when line and plane are parallel, dot of b and n is 0, and when line is perpendicular to the plane, their cross product is 0. Okay, now third possibility is that line is lying on the plane. So let's draw the plane once again. Okay, line is lying on the plane, so let's draw line on the plane. This is point A through which line is passing, and this is vector to which line is parallel. Draw the vector which is normal to the plane. So this is vector n normal to the plane. Okay, for this situation, for this positioning of line and plane, obviously the first condition is b dot n is equal to 0. Here we can see vector b is normal to vector n, so their dot product is 0. Also point A is lying on the plane. That means point A will satisfy the equation of plane. So we have A dot n. I am putting point A in the equation of plane. So A dot n is equal to D. Here A dot n not equal to D because line is parallel to plane, not lying on the plane. Here line is lying on the plane. That means point A will satisfy the equation of plane. So here we have A dot n is equal to D. So both these conditions together are the conditions for line lying on the plane. And the fourth possibility is that line is inclined at an angle theta with the plane. So for that we have this plane, and line is inclined. So we draw a line like this. This is the point of intersection of line and plane. Okay, and this angle is theta. In this case, none of these conditions will be satisfied. It may happen that the point A of the line is lying on the plane, but apart from that, none of these conditions will be satisfied by this positioning of line and plane. In this situation, we will be finding inclination of line with the plane using dot product. This line is along vector B, and normal to the plane is vector n. So we can see there is some angle between vector n and b, which is this angle. This angle is pi by 2 minus theta, which we can find using dot product. Okay, now let's consider one real situation when the equation of line and plane are given. Okay, now consider equation of line as x minus 1 upon 1 is equal to y minus 2 upon minus 3 is equal to z plus 1 upon 4, and equation of plane as x plus y minus z plus 2 is equal to 0. Now we want to draw this line and plane. The first thing we will check vector of line and vector which is normal to the plane. Now what is vector along the line? Suppose that vector is B. What is that vector? That vector is from this values 1, minus 3 and 4. So vector is I minus 3j plus 4k. And vector normal to the plane is vector n is equal to, that will get from coefficients of x, y and z, that is I plus j minus k. Okay, now these two vectors are not parallel. That means the line is not perpendicular to the plane. Also, if we take a dot product of these two vectors, so we have b dot n is equal to 1 minus 3 minus 4, and this is not equal to 0. That means line is not lying on the plane. Also, line is not parallel to the plane. That means here line and plane are inclined to each other at some angle theta. Okay, now let's draw plane and line. So here we have plane. Okay, now line is inclined at some angle to the plane. So let's draw line like this. This is point of intersection of line and plane. Now suppose we want to find this point of intersection. First of all, let's put a point on the line. Line is passing through the point 1, 2, minus 1. So let's put this point. This point is suppose P, through which line is passing. It is 1, 2, minus 1. Now how you get this point of intersection? Suppose this point is Q. How you get this point? Let me put here element number 1. This is point of intersection of line and plane. Now from the equation of line, we can write general point on the line. What is general point on the line? If I consider x minus 1 upon 1 is equal to y minus 2 upon minus 3 is equal to z plus 1 upon 4 is equal to lambda, then point on the line, any point or general point on the line is lambda plus 1 minus 3 lambda plus 2, 4 lambda minus 1. Now where is this point on the line? This point may be here, 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 or anywhere on the line for different values of lambda. If you take different values of lambda, you will find a number of points, but all those points will lie on this line somewhere. That means there will be some value of lambda if this point represent point Q. Now how we get that value of lambda? It's simple. At that time, this point will lie on the plane. So let's put this point in the equation of plane. We have lambda plus 1 minus 3 lambda plus 2 minus 4 lambda plus 1 plus 2 is equal to 0. Let's get value of lambda from this. We have lambda minus 3 lambda minus 4 lambda. That means we have minus 6 lambda. And then we have 1 plus 2 plus 1 plus 2. It is 6. So plus 6 is equal to 0. So we get lambda is equal to 1. Okay. Now putting this value of lambda in this, we get point Q, because this value of lambda is for point Q. So we get point Q as 2 comma minus 1 comma 3 by putting lambda in this. So we have coordinates of this point 2 comma minus 1 comma 3. Okay, so this is element number 1, point of intersection of line and plane. Now element number 2, I want to find foot of perpendicular from point P on the plane. What I am doing, from point P I am dropping perpendicular to the plane. Suppose this point is R. I want to find coordinates of this point R. Now we can say point R is a point of intersection of line PR and plane. But for that we must have equation of line PR. Now tell me, how can we get equation of PR? Line PR is passing through point P. So we have a point on the line. Now we need direction of PR. And that is simple, because PR is perpendicular to the plane and normal to the plane is a vector. Normal to the plane is I plus j minus k. So we can say line PR is along vector I plus j minus k. So the equation of line PR is x minus 1 upon 1 is equal to y minus 2 upon 1 is equal to z plus 1 upon minus 1. Now suppose this is equal to mu. So we get general point or any point on this line as mu plus 1, mu plus 2 minus mu minus 1. Now for point R, there is one unique value of mu. How can we get that unique value of mu? Point R is lying on the plane. Okay, so let's put this point in the equation of plane. We get mu plus 1 plus mu plus 2 plus mu plus 1 plus 2 is equal to 0. Now we have this is 3 mu plus 6 is equal to 0. So the value of mu is minus 2. Putting mu is equal to minus 2 in this, we get coordinates of point R. The coordinates are minus 1, comma 0, comma 1. So these are coordinates of point R. So we got foot of perpendicular from point P on the plane. Okay, after getting this foot of perpendicular, we can get image of point P in the plane. Now where will be image? Image will be here. Suppose this is image S, then distance PR is equal to distance RS. That means R is midpoint of PS. We can get coordinates of point S. Okay, here we have 1, here we have minus 1. So here we must have minus 3, 2, 0. So here we have minus 2, minus 1, 1. So here we have 3. So this is image of point P in the plane. Now suppose I join these 2 points. Okay, can we say this is projection of this line in the plane? If I extend this, this is projection of line on the plane, and now we can get equation of this projection. Okay, so let's write element number 3, projection of line on the plane. Now we have points Q and R. We can find equation of this line. The equation of line is x minus 2 upon 2 minus minus 1. So this is 3. Y plus 1 upon minus 1 minus 0. So here we have minus 1, and z minus 3 upon 3 minus 1 is equal to 2. So we have now equation of projection of line on the plane. Also we can get equation of image. This QS is image of this line in the plane. Now we have points Q and S, so we can get equation of this image. Okay, equation is x minus 2 upon 2 minus minus 3, that is 5, is equal to y plus 1 upon minus 1 minus minus 2. So here we have 1, and z minus 3 upon 3 minus 3, that is 0. So we have now equation of projection and equation of image. Okay, now how can we find angle between this line and plane? Suppose this angle is theta between plane and line. How can we get this angle? For that, from this point, let's draw vector normal to the plane, which is I plus j minus k. So let's write this vector here, I plus j minus k, and this vector is difference of these 2 points, which is minus I plus 3j minus 4k. Now this angle is pi by 2 minus theta. So we have now element number 5, angle between plane and line. Here we have cos pi by 2 minus theta. This is equal to dot product of these 2 vectors, that is minus 1 plus 3 plus 4 upon square root of, okay, now here we have square root of 1 plus 1 plus 1. So here we have 3, and here we have square root of 1 plus 9, 10 plus 16, root 26. So we have sin theta is equal to 6 upon root 3 multiplied by root 26. So theta, which is angle between line and plane, is sin inverse 6 upon root 78. So we can see that here we have many activities for line and plane. We have a point of intersection of line and plane. We have foot of perpendicular of point P on the plane. Then we have image of point P in the plane. We have equation of projection of line on the plane. Then we have equation of image of this line in the plane. And finally we have angle between line and plane, which is angle theta. Okay, now consider this question. The question is find the distance of point 2, 3, 1 from the plane x plus y minus z plus 2 is equal to 0. Measured parallel to the line x minus y upon 1 is equal to y minus 2 upon minus 3 is equal to z plus 1 upon 4. So again here we have line and plane. So let's first of all draw this line and plane. Here we have plane. Okay, equation of this plane is x plus y minus z plus 2 is equal to 0. Normal to this plane, vector n is equal to I plus j minus k. Now we have line. How you draw this line? First we have to check the vector of line and vector which is normal to the plane. Now vector along line is, suppose that is vector b. Vector b is I minus 3j plus 4k. Now these two vectors are not collinear, they are not parallel. That means line is not perpendicular to the plane. Also, if we find dot product of these two vectors, we have 1 minus 3 minus 4 not equal to 0. That means line is not parallel to the plane. Also, we can say line is not lying in the plane. That means line makes some angle theta with the plane. So let's draw the line like this. This is point of intersection of line and plane. This line is passing through point P having coordinates 1, 2, -1. Okay, the vector along the line is vector B, which is I minus 3j plus 4k. Now we have point 2, 3, 1. Where you put this point? Now this point is not satisfying the equation of plane as well as equation of line. That means this point is not lying on the plane. Also it is not lying on the line. So let's put point 2, 3, 1 here. Suppose this is point Q, 2, 3, 1. Now we have to find distance of this point from the plane. But that distance is measured parallel to this line. That means certainly this distance is not a shortest distance, not a perpendicular distance. So from point Q, let's draw a line parallel to this line. Suppose this is a point of intersection with plane and this point is R. We have to find distance QR. Here we can say distance QR is distance of point Q from this plane measured parallel to this line. Now to get distance QR, we must have point R, and we can get point R by solving this line and plane. But for that, we must have equation of line QR. So now the task is equation of line QR. How we get this equation? This is passing through point Q and parallel to this vector B. So equation of line QR is x minus 2 upon 1 is equal to y minus 3 upon minus 3 is equal to z minus 1 upon 4. Suppose this is lambda, so we get general point on the line as lambda plus 2 minus 3 lambda plus 3, 4 lambda plus 1. Okay. Now we want point R, so for that I will put this point in the equation of plane. We have lambda plus 2 minus 3 lambda plus 3 minus 1 minus 4 lambda plus 2 is equal to 0. Let's solve this. We have lambda minus 3 lambda minus 4 lambda, that is we have minus 6 lambda, 2 plus 3, 5 minus 1, 4 plus 2 is equal to 6. So we have plus 6 is equal to 0. From this, value of lambda is 1. So if I put lambda is equal to 1 in this, I will get point Q, because this value of lambda is corresponding to point R, which is lying on the plane. So putting lambda is equal to 1, I get point R as 3, 0, 5. Okay, now we can find distance QR using distance formula. Distance QR is equal to square root of 3 minus 2, 1 square, and 0 minus 3 square, plus 5 minus 1, that is 4 square. So we get this distance as 1 plus 9 or 10 plus 16 root 26. So this is distance of point Q from this plane measured parallel to this line. Okay, let's see this next question. Now we have to find distance of point 2, 1, minus 7 from this line, which is measured parallel to this plane. Again, we have same line and plane which we had in previous question. So let's draw line and plane. Here we have plane. Equation of this plane is x plus y minus z plus 2 is equal to 0. Normal to this plane is vector n, which is I plus j minus k. Okay, now let's draw line. Here we have line. Okay, equation of this line is x minus 1 upon 1 is equal to y minus 2 upon minus 3 is equal to z plus 1 upon 4. This line is passing through point 1 comma 2 comma minus 1. Suppose this point is P. Now we have one more point in the space, that is 2 comma 1 comma minus 7. We can check this point is not satisfying the equation of line as well as plane. That means this point is not lying on the line and not lying on the plane. So let's say point 2 comma 1 comma minus 7 is somewhere here, point Q. Okay. Now we have to get distance of this point Q from this line, but which is measured parallel to this plane. So how can we draw this distance? It is this distance. Suppose this point is R. Now how this distance QR is drawn? This QR is parallel to this plane. For that, let's draw one reference line here on the plane so that we can feel that QR is parallel to this plane. We have to get distance QR. How can we get this distance? We have coordinates of point Q. So we will focus on point R. We will get coordinates of point R. Now point R is lying on the line. So how can we get coordinates of point R? We will consider general point on the line. Suppose this is lambda. So general point on the line is lambda plus 1 minus 3 lambda plus 2, 4 lambda minus 1. Suppose this point is R. That means for this point we have one unique value of lambda. How can we get this value of lambda? Now how point R is situated? Here QR is parallel to the plane. That means QR is perpendicular to normal to the plane. So let's draw normal to the plane. Here we have normal. This is a vector n. Okay, this vector is I plus j minus k. Now these two vectors are perpendicular. That means dot product of vector QR and n is 0. So we have vector QR dot n is equal to 0. Vector QR is lambda plus 1 minus 2, which is lambda minus 1 I minus 3 lambda plus 2 minus 1. So we have minus 3 lambda plus 1 j. 4 lambda minus 1 minus minus 7. So we have 4 lambda plus 6 k. This is vector QR dot n. We have I plus j minus k. This dot product is 0. Okay, now let's get the dot product. We have lambda minus 1 minus 3 lambda plus 1 minus 4 lambda minus 6 is equal to 0. Simplifying this, we get minus 6 lambda minus 6 is equal to 0, or lambda is equal to minus 1. Now this value of lambda is corresponding to point r. So let's put lambda is equal to -1 here. We get this point as 0 plus 5 comma -5. So we have now coordinates of point r. We can find distance qr using distance formula. Distance qr is equal to 2 minus 0 square, that is 4, plus 1 minus 5 square minus 4 square, that is 16, plus -7 minus -5 square, that is 4. So this is square root of 24. This is equal to 2 square root of 6.